All right, we're back. We're on page 62 of math analysis. We're in note 6, and what we're talking about is inverse trig functions. We know a lot about them at this point. We know a bunch of key points. We know what we need to memorize, so we should have memorized it. And now what I'm going to do is try to do some problems that sort of relate to this. And there are a couple like little tricky issues with inverse trig functions that we're going to start talking about here. And you're just going to keep running into them like throughout your math career, basically. So one way to look at this problem is we want to evaluate, that just means like find the value of sine of the inverse sine of negative root 2 over 2. All right, so one thing that you can do is you can say that this is an angle, right? So we could say it's theta. So really, if I say that theta is sine inverse of negative root 2 over 2. So I have memorized that the inverse sine of negative root 2 over 2 is negative pi over 4. I have a lot of ways that I could work that out if I didn't know that. Primarily, I would draw this little picture. And then I would like think about it. But I know that it's negative pi over 4. So theta is actually negative pi over 4. So really what we're doing here is we're trying to find the sine of negative pi over 4. But I just said that the sine of negative pi over 4 is negative root 2 over 2. That's how I found negative pi over 4. So this is just going to collapse down to negative root 2 over 2. And that's kind of interesting, and we want to like think about that a little bit more. But before we think about that, let's see what our intuition tells us about the next problem, right? So the sine of the inverse sine of negative root 2 over 2 is just negative root 2 over 2. So this feels like it might be simple because we're dealing with a function and its inverse. And when you compose a function with its inverse, you just get, f of f inverse of x is x. So it makes sense to me that we just got kind of x, right? Well, what about this? I want to do the arc sine of the sine of 7 pi over 6. So like maybe your intuition is saying it's going to be 7 pi over 6. There's a problem with that. 7 pi over 6 is not in the range of arc sine. So it can't be what this evaluates to. So we're going to have to take this a piece at a time. So the first thing I'm going to do is say that really, I was going to try to write arc sine, but then I decided to do inverse sine. That's why that S is crazy. What is the sine of 7 pi over 6? Well, it's negative 1/2. Why do I know that? Because I memorized it. Memorize things, people. When you have them memorized, it's so much easier. It's like learning to read, right? Like you don't have to sound out every word because you know them. All right, sine inverse of negative 1/2. Okay, so that's going to be the angle between negative pi over 2 and pi over 2, whose sine is negative 1/2, which is going to be negative pi over 6. All right, there's a kind of a weird, so there's a lot going on here. So here, when I was doing the sine, the normal trig function of the inverse trig function, it just reduced down to this. When I did the inverse trig function of the normal function, it did not reduce down to this. Sometimes it might, but not always. So I'll be honest, on these problems, I always just do all the steps. I've never bothered to like think too deeply about this concept, but it wouldn't be bad if I tried to. But what's happening here, let me write this one out kind of in words, right? So here, this is asking me to find the sine of the angle whose sine is negative root 2 over 2. That's what this is saying. Find the sine of the angle whose sine is negative root 2 over 2. So I kind of like skipped a little part of the angle. Let me move this because it should be, between negative pi over 2 and pi over 2, whose sine is negative root 2 over 2. Like what could, it's like one of those like dumb, it's like a dumb logic puzzle where like find the sine of the angle whose sine is negative root 2 over 2. Like it has to be negative root 2 over 2. This, on the other hand, is saying what is the angle between negative pi over 2 and pi over 2 whose sine is the same as the sine of 7 pi over 6? It's not really the same question. I don't want to write that out. That was a really long sentence. But this is saying, so you can actually do something. I do something with pictures with these a lot. And you'll see when they get weirder, this is a very useful idea. So this is my unit circle picture for arcsine, right? The angle that I'm actually dealing with here is 7 pi over 6. So where is 7 pi over 6? It's like here. So what I want is I want the angle that's in here that has the same sign, the same y value as this angle. So you can actually just by symmetry, you can see that that's going to be, just reflect it over here. And then you kind of know, right? Like this was a pi over 6 reference. So this is a pi over 6 reference, but since it's this way, it's negative pi over 6. And that's actually the answer that we got. You can solve most of these problems that way if you choose to think about it. So you should definitely do that. I mean, thinking is the easiest way to get your way through things. So look at this. This is the scenario where I'm asking you, what is the tangent of the angle whose tangent is negative root 3 over 3? It doesn't matter what the angle is, right? What's the tangent of the angle whose tangent is 1/8? It's 1/8. What's the tangent of the angle whose tangent is 57? It's 57 because I'm asking you for the tangent of the angle whose tangent is. I'm giving you the answer. So this is definitely going to give me negative root 3 over 3. If I did it a piece at a time, I would view the tangent of, so what's the inverse tangent of negative root 3 over 3? Well, it's going to be, it's negative, and then it's a pi over 6 angle, so it's negative pi over 6. But then the question is, what's the tangent of negative pi over 6? It's definitely negative root 3 over 3. So, knowing these things makes it a little easier. I think that showing the steps works, though. And I do it all the time because obviously you're less likely to make a mistake when you're showing all your work. So here I'm looking for the angle whose tangent is the same as the tangent of 5 pi over 3. So the angle, but there's more to that, right? I really want the angle between negative pi over 2 and pi over 2, not inclusive, so exclusive, whose tangent is the same as the tangent of 5 pi over 3. Well, if we draw our picture again, so inverse tangent, you got open circles. Where is 5 pi over 3? So 5 pi over 3, which is the angle we were given, is actually here. It's actually in the quadrant. But we're not allowed to use that, right? So this is 5 pi over 3. But if you go outside of the part of the circle you're allowed to be in, you broke the rules. So you can't get there. But there's another way to get there. The other way to get there is to go this way, negative pi over 3. So this answer is negative pi over 3. I don't know why I'm cramming everything in there. Well, I didn't really plan to write there, I guess is why. So it's different. This is different from the previous one. The previous one was like a dumb logic puzzle. This one is a real problem that you need to solve. So here, if I did it a piece at a time, I would be doing the tan inverse of what's the tangent of 5 pi over 3? It's pi over 3, which means its tangent is radical 3, but it's in the fourth quadrant, so it's negative. So it'd be negative radical 3. And then I just think what angle between negative pi over 2 and pi over 2 has a tangent of negative root 3, and it's negative pi over 3. You get the same answer either way. So there's like a lot to think about here, but they're not really that bad. So what do I have left here? I think I'm gonna stop this here because these are like really important ideas. You got to think about them. There's like, you can make up basically an infinite number of these, do whatever you want, and you can work them out. I'm going to come back in the next video and do the rest of these, and we will continue from there. So spend some time thinking about these, especially the sentence that I wrote and the sentence that I didn't write because it was too long, but maybe go listen to that again. But anyway, I will see you in the next video.